Okay, so welcome to the August Bridge Builder Seminar. We're very glad you're here. We thank you for taking the time to spend Saturday morning with us and listen to these fascinating talks that reveal God through His creation as well as His Scripture. Let's open with just a brief prayer. So, Heavenly Father, we come here today to praise you, praise your name, and see how you and your glory are revealed throughout creation. Father, bless our speakers today as they bring the truth of who you are through their presentations and open our eyes to just how magnificent you are. In Jesus' name, amen.
Amen.
So our first speaker is Mike Miller. Mike has a degree in chemical engineering and graduate studies in polymer science. Mike's career has spanned over 49 years in the tire and rubber industry and is currently retired. So Mike, please tell us about creation where the rubber meets the road.
Okay, well, thank you. Yeah,
Retired.
I'm getting retreaded. That's retreads now, but anyways, thanks for coming to this presentation. Can you hear me? I want to start off by telling you how I got here. We've been coming, Alice and I, my beautiful wife, and I have been coming to Fort Worth Press since 2010, and we've been in various Sunday school classes, what we call Christian formation classes now, over the years. But in the last couple of years, we've been in Bob's graduate school level Sunday school class. And we bought a couple tickets to Bob and Marilyn's backyard party last May. And Bob and I had a side conversation. And you know, when you have a side conversation with Bob, you know what you're going to talk about. So we started talking about rubber. I guess he had some sort of questions about rubber, like a nitrile gasket or something. And I told him, then I started on, you know, my whole career, 49 years in the rubber and plastics business, and I was talking to him about that. And then it got to where I started talking about tires. In the first 7 years of my career, I was in the tire business, Firestone over in Tennessee. But I had mentioned some things to Bob about what tires and what I look for in tires since I was in the industry. I don't know if anybody's been in that industry either, but and he said, well, that's some information that I think everybody needs to know. So that was part of it. The other part of it is then we started discussing God on a molecular level. It's something that you really never think about. Our eyes, who Dr. Sands is going to talk about, can only see at a certain level. We can see finished products and we can see aggregates of molecules, but we can't see the actual molecule itself or the atom. And I'm kind of thankful for that too, because I think if everybody could see what was going on in front of us, it would be like a horror movie with all these atoms floating around and things like that. So I'm thankful that God didn't give us the eye vision of an electron microscope. But anyways, and I'll tell you how I got in. Anybody in here ever dream of being about a rubber chemist? I didn't think so. Neither did I. So I started school out in California. I had lived in Tennessee before. My father was in the Air Force, and we had lived out there in the 60s. And I decided to move to Tennessee and go to school, finish my school there. And I needed a job. I was working my way through college, and my friend, who I'd met before back in 8th and 9th grade, was working at a Firestone truck tire plant in Smyrna, Tennessee, which is south of Nashville. And I needed a job. So he helped me get a job in the lab. And in 1975 until last year, I've been in the rubber and plastics business. And it's a fascinating industry. People don't even think about it. Everybody sees tires. It's a commodity, and nobody really thinks what goes into a tire. You know, Dowell and I were talking about tires being black and carbon. Well, I'll get to that in a little bit later. Anyways, it's a fascinating industry. Rubber is a commodity or a material that can be shaped, molded, and compounded to just about anything you want to. And it's just not tires, not rubber that goes in the tires, but there's, 15, 20 different polymers as far as rubber is concerned, and there's a myriad of plastics that go into what we have today. You know, I always say that if you take rubber and plastics out of this world, we'd be back in the 1800s, or hydrocarbons or whatever, what do you want to call it. But anyways, it's a fascinating industry. I enjoyed it, and I spent time in the tire industry the first 7 years, and then I was in industrial rubber facilities. I've been in aerospace and military. In the last number of years, I've been here in Texas, and everybody in Texas is oil and gas. So I've been in all those industries with rubber, and it's been really a fascinating time that I appreciate what God and how He moved me to be standing here in front of you talking about this today. And you got to hand it to bridge builders. I've been in other churches, and I've never really had anybody talk about God on a molecular level. And that's what I'm going to talk to you about today. And let's get started on this, because I got a half an hour and I got 27 slides. So, wrong. I want to. I'm not here to give you a Sunday school class, and I'm not here to give you chemical class, because that would take a couple semesters. And I'm not qualified. I'm not a professor. I leave, the Sunday school and the professorship to Bob. So he can do that. I will just give you an overview of what I have learned over the 49 years that I was in. Anyways, the first two, Isaiah 40, 21 and 22, and Proverbs 8:27, if you can see those, what saved the flat earthers a bunch of heartache or heartburn back when they thought the earth was flat. If you read the Bible, here it spells out God created a circle of the earth. And also in Proverbs, I was there when he drew a circle of the face on the deep. A circle. Now, if you think about it, how many things are round in these days? You get a can of soda, you get steering wheels, and what I'm talking about is tires. But if we didn't have the perfect design that God provided to us, can you imagine square tires or anything like that? So he's the master designer, and that's why I put those in here. And I think about it all the time when I'm looking at tires and stuff like that. Why everything's round? It's it's aerodynamic and it's efficient. And then we also were talking about, Bob, in the backyard, about how God gives us knowledge. And you got Proverbs, you got Philippians, and you've got those Psalms. And you can read those. I don't need to read them to you, but God gives us the knowledge. And then he gives us understanding, which is down here, and to fill his purpose, and gives us understanding. He gives us the knowledge of something, and then he gives us the understanding of it. So if you look at water, water's water. But to understand it, it's H2O. Okay, and then, like Bob and I were talking about, you can take that and with the understanding, and you can have the wisdom that comes along with that to do what you can with water. But I wanted to share those two, because it's something I've been thinking about. I became one of... I came to Jesus when I was 27. And I was in the business for 7. I'm sorry. I'm sorry. Anyways, I've been in business for 7 years when I started my career, and I never thought about it. But when I came to Christ, I started thinking in other ways because, I'm a chemist and things like that, and it's just amazing. It just blows you away what Christ has, or God, triune God has given to us. So I wanted to share that too. And here's creation on a scientific level. Bob, if I say something wrong, let me know. The first day is light, and the only thing I can think of as light is the glory of God, because it doesn't say anything about sun or anything like that. There's light and the glory of God that we will see in eternity. The second day, heaven. It's above my pay grade. I don't know what heaven's going to be made of, so I can't put that down. But on the third day, that's when it starts getting, that's where it starts getting interesting. The earth, water, sand, vegetation, the periodic table that Bob talked about a couple programs ago, and the atmosphere. All those are chemicals. We can see the air. We can't see the air, but we know through the understanding of what God has given us what it's made of. 78% nitrogen, 21% oxygen, and about 15 other gases that make up the atmosphere. And then chlorophyll, when he put vegetation on the earth. Chlorophyll is part of the photosynthesis that the leaves and everything goes through to turn carbon dioxide back into oxygen. Anyways, and then on the fourth day, the sun and the moon. Then that's where we get UV and ozone. Ozone is a pretty harsh element that is mainly up in the stratosphere, protecting us from the UV from the sun, but it's also down here. And I'll get into ozone. It attacks tires, anyways. And then animals and sea creatures, and then I skipped that one. And then on the sixth day, the man and woman. There's 6 elements that make up 99% of the human body. And I'm sure if there's a physician in here or everybody knows that. But you got carbon, oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus make up 99% of our bodies. So on an elemental level, God, when he spoke this into creation, this is what we have, and something that we can understand now. 5,000 years ago they couldn't do that, but right now we can understand it. But speaking all this into creation is it's just amazing to me. It's just amazing to me. And then on the seventh day, you said all is good. Chief chemist, physicist, biologist, and astronomer. In my estimation, God is the chief of everything. And he gives us this knowledge and for his purpose, like the verse that I had put up there. So this is something that I wanted to share while on this presentation. And then Bob's presentation was on the elements. This is going to be more of a wait a minute. There. This is an organic chemistry class. I got a C in it, so I'm just average. And usually you take this in your junior or senior year, so it's not a freshman class. And it's very complicated, very complicated. And then what we're really going to be talking about is another subdivision of organic chemistry, which is hydrocarbons, which is elements that deal with hydrogen and carbon. So organic chemistry is the study of carbon-based chemicals like diamonds and sugar and everything. And then you got hydrocarbons, which mainly is petroleum-based, but there are other hydrocarbons. And then I also wanted, we're going to build a tire while I'm talking here. The polymerization is the start of the rubber process and making polymers. And some terms that will be used, amorphous and crystalline, that's the orientation of the long chains. We're making long chains of molecules that we're going to polymerize together. And if you, an amorphous polymer, which we're going to be talking about, SBR, is the polymer chains are put together in a random fashion. And it's like if you can picture a bowl of spaghetti. And that's how that chain that looks like. And if we could see that, you would look like a bowl of spaghetti. And then the crystalline is a polymer that the polymer chains are like guitar strings, where they're symmetric and they're not all over the place. They're straight. So that's how you can picture that crystalline. Polar and nonpolar, that's deals with the polarity of the molecule. A polar compound, like water. Water is a solvent actually. The ends of the polymer chain have a charge on them, and they're not balanced. Nonpolar is exactly the opposite. The chain is balanced at the end of the molecule. So, and in chemistry, likes will be miscible with likes. In opposites, water is polar. The rubber compound is nonpolar. So they're not going to, water is not going to dissolve in the rubber. But on the other hand, petroleum is nonpolar, and the nonpolar rubber, you will have a degradation by the oil itself. So part of my, at the end here, don't let your tires sit in oil. That's not going to be a good thing for them. And cross-link, that is the bond that we'll get into when we get to the vulcanization. Is a bonded short sequence of bonds that links one polymer chain to another, which will have a sulfur bridge for that. And then glass transition is the temperature at which the rubber will turn into glass. And polybutadiene is like a minus 100 C. At that temperature, you can take it with a hammer and break it. It's above that temperature, it will be a flexible material. But you've also got to consider that when you are compounding a tire, you got to compound it for Minnesota, and you got to compound it for Texas. So it's somewhere in between. So that's the key to that. And then when temperatures start getting too low, the performance of the rubber deteriorates, and it starts getting stiff, and it doesn't work like a rubber should. So that's something that you need to keep in mind too. Okay, let's do polymerization. That's where we take two monomers, styrene. We're going to talk about SBR. There's other ones that we don't have time to do, but we're going to talk about, this is the most widely used rubber in the world. It's 60% of all the production because it goes in tires. And I think a little bit later on, I'll tell you that there's a 1.5 billion cars in the world. And so that means there's 6 billion tires at any point in time on the ground. That doesn't include trucks or buses. So if you include those, it's over 2 billion vehicles, and you got an 18-wheeler out there with 18 tires on it. So it's a tremendous amount of this SBR is used. But what happens is you got two monomers, styrene and butadiene. It goes through a catalyst that will start the reaction, and a soap solution like stearic acid that will emulsify it and kind of lubricate things as it's going through. It goes into the reactors, and then the long chain. This is right here. This is the structure. This is the structure. Here's a styrene unit. It's got the benzene ring, what they used to call before cancer was. Anyways, it's an aromatic ring with 6 carbons and 6 hydrogens around it. It's more of a plastic. Then you got a butadiene, which is very resilient rubber. And what it is, it's 75% butadiene, which I'll show you a little bit later. It's Super Bowl over there. And then you've got plastic, and you can't have tires made out of plastic. It's not going to work. But the butadiene is very resilient, the glass transition, like I said, was minus 100. And so it's just, the polymerization, they put these chains together like this. And these right here, these double bonds, is what we're going to be talking about a little bit later. What it does, it goes through here, they strip it off because it's not it's not a perfect reaction, so they strip off the butadiene and styrene is not used in, that is volatilized off. And then it goes through the stripping vacuum flash tank, and then down here they dewater it and process it into what's right. This is the actual. I better walk around this way. If you can read that, but, monomer goes through here, the water, the emulsion bath, and then you got the cells, and then the polymerization takes place. And this is what you get. Bales of rubber. This is SBR, and it's after it's been polymerized and dried and packaged. And the question is, I thought tires were black. They don't start out black. Now, the white wall tires back in the day when most of us, well, a lot of us old people had white wall tires. And if you didn't have white wall tires, you weren't cool. But anyways, they would color the rubber with titanium dioxide to make it white and put a strip under it. They don't do that anymore. It's not cool. So this is the formulation of a tire tread material. So you just don't realize what actually goes into the compound itself. And the styrene, butadiene that we just polymerized, and then we got polybutadiene, they add that because it's really a very resilient material. And then we've got zinc oxide and the fatty acid, which is stearic acid, that is an initiator of the reaction when you cure it with vulcanization. We'll get that a little bit later. And then, like I was saying before, the antioxidant, antiozonant, an unsaturated polymer is subject to atmospheric attack, which is UV, ozone, and oxidation. And if they don't have those compounds in it in this formulation, the rubber will eventually and very quickly degrade. Because what they do is the ozone will break those double bonds that I showed you. The ozone will break these double bonds and deteriorate the rubber because it just kind of breaks the chain, the polymer chain. And the vulcanizing agents are sulfur and then some accelerators. And the process oil, if it didn't have processed oil, it's naphthenic or aliphatic or paraffinic oil, depends on the compounder, it would not be processable. And also it helps in colder weather, or making it less subject to that glass transition that I was talking about. And then carbon black, that's what makes the tire black. And Dowell and I talked about that last week, I think. And we got a carbon black manufacturer whose headquarters is here in Fort Worth, Sid Richardson, but that was bought out. And we still have plants in Big Springs, and there's one over in Louisiana, and I forget where the other. There's two in Texas. In
Texas.
huh?
Texas.
The what?
Texas.
Yeah. Anyways, the carbon black is what makes the tire black, but it's also a reinforcing filler. What it does, it rides on the polymer chains and that spaghetti that I was talking about, and it reinforces the rubber. Rubber without reinforcement is rubber. And I gave you some bubble gum there. And that's what you got. That's what you got before reinforcement in vulcanization. But this is a typical compound, and there's all the tire manufacturers do a little bit different. And you can vary these. It's unbelievable how many times you can, or how much you can vary these. This compound. Okay, now you've got all this compound, or the formulation, or the recipe, whatever they call it. You've got to mix it. You got to take the rubber, those bales that I showed you. And when I first started with Firestone, I worked on the production line. Everybody that went into the lab had to work on a production line for 6 months. And every 7-8 minutes, you got to load. This is it's a big band breeder that we had. Load 75-pound bales on a belt. And I used to, in Tennessee, these guys that come out of the country, and they're roofers and things like that. Here's old skinny Mike, and I'm sitting there going like this. I want to go in the lab. I want to go in the lab. I want to go. Yeah. Well, I had to do that for 6 months in the band breeder. I don't know why they stuck me in there, but anyways, they load all this material, and it's dumped into. Let me go around this way again. It's dumped. This is under these rollers here. That it's like a mixer. They're going like this. Very high. We were doing 900 pounds every 6 or 7 minutes, and it mixes, and then it dumps out of the chute here onto this. This is turning into black now. It dumps onto the chute, onto this, and then they roll it up, mill it out, and for other processes down the road in the tire plant. And that's what it looks like after it's mixed, after that formulation there. And here's the composition of your tire: carbon black, high tensile strength steel, polyester. Now they use aramid fiber, Kevlar. And I'll show you a schematic of a tire, and you'll see what these are. And then in the truck tires, the big truck tires, there's more natural rubber. Natural rubber is a little bit tougher than the synthetic rubber. And then this is the kind of makeup of an average tire. Okay, styrene butadiene. We talked about that. You can read it. This is what amazes me about what God has done for us. Look at how complicated that sounds, and He just spoke it into existence. I mean, like I said, I got a C in organic chemistry. So,
I have a question. Do you use a free radical like hydrogen peroxide to begin to initiate the polymer reaction?
you can use that, yeah. Yeah. Free radical, you're right, free radical compounds. And you see the double bonds on there, that's called an unsaturated polymer. It's got those double bonds, and that's where we use those double bonds to think of the spaghetti, hooking the polymer chains together, basically sulfur. But they got sulfur, I'll get into that too. And then butadiene rubber is a very resilient material. We're all old enough to have a Super Bowl, right? If you weren't a cool kid, if you were a cool kid, you had a Super Bowl, a Slinky, and a yo-yo. And this is butadiene rubber, and it's very resilient, even bouncing in on carpet. And when we made these at Firestone, what we would do is go to the roof of a 3-story building, drop them off, and if it didn't rebound up to a point, they were rejected. But you can't make a complete tire out of this, otherwise you'd be bouncing down the road. So that's, I mean, but SPR, that's why they got this styrene in with the butadiene to kind of lessen that. But anyways, and then butadiene rubber, and then butyl rubber. This is really interesting. That's why I gave you this bubble gum here, and if you can take as much as you want, I've got 380 pieces. Give it to your grandkids. But butyl rubber is very unique in the fact that it's impervious, not impervious, but it holds air. You take a bubble gum, chew it up, blow a bubble. So what they use butyl rubber for is the inside, and you got a pneumatic tire that no tubes in them. We're also probably old enough to have seen tube tires, but that's where you got tubeless tires, butyl rubber. And the reason for that is that the molecular structure doesn't move much. So it just traps the air, and it will eventually go flat, let the air out. But if you had a natural rubber bladder, it would last maybe 10 minutes, 35 PSI of tire pressure or PSI air pressure, it would just bleed out. But that's a very unique material. It's a saturated material, and it's not the ozone attack or the atmospheric attack doesn't affect butyl rubber like it does the natural rubber or the SBR. And natural rubber has been around, I think, since the creation. They've got records of 3,000 years ago, of maybe even more than that, 4,000 years ago, of people using natural rubber. It comes from the Hiva tree, Brazil, Malaysia, and Indonesia. And what they do is they kind of spiral cut the tree, and the natural rubber or latex will bleed out of the tree, and they capture that, and then they process it, and it turns into it comes in bales also. But there's also a synthetic natural rubber called isoprene, and that's more of what they use these days because natural rubber has gotten more expensive. But that's what they first started using when they started using rubber for tires, natural rubber. And this is the important, I should have probably put that later, but these are the important properties for tire performance. And I won't go over most of those. The biggest thing is elasticity, resilience, and tear resistance, obviously, abrasion resistance, and thermal stability, grip and traction, the coefficient of friction, and grip performance. Now, if you think of a tire, what it actually goes through on the road, nobody ever thinks about it. You got a 5,000-pound car, and you got 4 contacts, probably, I don't know about that much, 4 different tires. But you go around a corner at 60 miles an hour, 5,000 pounds, that inertia wants you throw you off the road, but it holds. And the biggest, and rubber is incompressible, and that's what happens. That's the physical property that keeps the rubber on the road. Because if you put pressure on it, it's going to flow, it's not going to compress. So you got the weight of a 5,000 pound car pressing on the pavement, and it keeps the rubber on the road. Of course, you got to have tires inflated and everything like that, but it's a really unique material. Okay, now we're almost ready to, we're going to build a tire. Now, the process before that, after that, when I showed you that mixer, there's upstream from actually building this tire, there's a piece of equipment called a calendar, and that's where they put those steel belts or the Kevlar belts inside and impregnate the rubber with it. And there's also a extruder, which looks like a Play-Doh factory. When you squeeze the rubber through it, it comes out in different shapes. So that's, that's prior to getting to this point right here. But I'll play this for you, it's only a minute. They're building a carcass of the tire right now. That's the inner liner right there, that's the butyl rubber. That's the tread. build another one.
How many can they build of those an hour?
Back in the day when we did everything by hand, and I can't remember how many they did an hour. It's a lot. Like I said, it's like the replacement market is 1.5 to 2 billion tires a year. This is worldwide, but that's a lot of tires. They
How's
could,
the tread?
huh?
How's the tread molded on?
We'll get to that.
Okay.
What you saw right there is the carcass. Still green, it hasn't been cured, and it's pretty useless. Whoop. Now, vulcanization. This is where we're almost ready to put the tire on the road. Vulcanization, it's named after a Greek god or something, Vulcan. Anyway, it's a curing process where we chemically take the sulfur in that compound that I showed you before, and also the accelerators that are sulfur donors, and through the at 200 and I think they cure them at 290 or 300 degrees. The process goes into what it does is that those double bonds will break, and these sulfur bridges will attach themselves to the two different polymers, and that's the mechanism to bond the polymer chains together, and that's when you start being able to use the tire. But they every, I don't know, we used to like 9 to 10 minutes they would cure. But that's the mechanism. And then when I first started to get into this polymers, they said that they could credit to Charles Goodyear for using the sulfur for vulcanization. And they said that it was by accident that he found that. It wasn't by accident. God gave him that knowledge because he needed tires for the horseless carriages that they had. So God, he provides everything. He gave Charles Goodyear the idea of using sulfur to cure it. So it's not nothing. There's no random molecule in the whole universe, and God gave them that Charles Goodyear that information. Oh, I'm way over. Oh, ooh. Okay. I'm gonna go back. I'll show you one more video, and then I'm sorry. Okay, this is what Dal was saying. This is the curing process. Inside those molds are the tread patterns. It's a segmented mold. And when the tire gets in there, it collapses and it's cured into that shape. I'm sorry. Okay, we don't need to see any more of that. This is the breakdown of a tire. I won't go over all these. That's the tread. There's a myriad of different tread patterns. Now the alphabet, I'll close with this. Alphabet soup that you see on the side of your tire. You got the P, which is a type, it's a passenger car tire. 235 is the tread width. Aspect ratio is 45, that's a pretty wide tire. And then 18 is the diameter of the wheel that you're putting it on, and it's load rating, speed rating. Well, we'll keep going here. Okay, this is what Bob and I were talking about in the backyard. This manufacture date, and I'll close with this. If you don't know what that means, then you don't know what it means. But what it is the 41st week of the year in 2018. I think that the tires should be, and that's what I do with Alice's car, change it every 4 years, no matter how many miles she got, unless it wears out itself on the way. I say 4 years because of the ozone attack, UV, everything like that. The standard in the industry is 6 years, but I'm a little bit more conservative. But I think everybody drives a car 10,000 miles a year, get 40,000 miles on in 4 years, you're doing good. But that's my opinion. But that's what I do. And there's one. But if you go, they may have a sale on tire and it hasn't been moving. So they put a sale on it and the tire might be 3 years old already. So what you need to do is when you go get a tire, ask the guys that put them on, when was it built? And I always get tires that are built the same year. And if you got a tire that, is pretty popular model, you're not going to have to worry about it because it's probably done in that year. But they have tires that have been sitting around a long time and they'll put them on sale. So you buy them. But, if you got a 3-year-old tire and like I said, even if you went to the industry standard, you'd have a 7-year-old tire, and you don't want that. And tires are expensive, but I'm also trying to make you realize why tires are expensive. And it's the only thing that hits the ground on a car, and it goes through a lot of abuse. And let me see. Okay, I'll really close with this. Make sure the tire is properly inflated. All the cars now, I think, have got that tire minder. You don't have to worry about it, but when it comes up, make sure your tires are, otherwise they'll wear out and they'll build up heat if it's underinflated, and they'll wear out if it's overinflated. Rotated and balanced. I always get one size larger tire. Say if you got a 275, I always get a 285. You got more rubber on the road, it's a little bit more friction, but it's more rubber on the road. The date on the tires, don't let your tires sit in any oil or anything like that because it'll deteriorate real quick. And I always buy the hazard protection because if you get a nail in it, they can plug the hole, but I don't believe in that. And if your tire is not black, not as black as it was when you first bought them, it's the anti-ozonants and everything in it to protect it have bled to the surface. And you'll get a little bit yellow, and you'll get a little. Anyways, and then don't run on bald tires because those treads are there for dissipating water. And I always use all-season tires here in Texas. I think you can get away with that because our winters are not that cold and our summers are hot, but not that hot. Not like it is in Arizona. But anyways, I'm sorry I ran over. I thank you very much. If you got any questions,